Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honest Geometry class. Today we're going to start talking about circles. A little brief introduction to circles. I added a lot more on my notes than what you're going to see on in your textbook. So please pay a lot of attention to this because it's very, very, very important, okay? First of all, guys, when we see a circle here, okay, this green line here, okay, this green line right here, if it goes through the center, and if you have a segment that goes through the center and hits the two endpoints of that segment are on the circle, that's called the diameter. So the diameter goes from one point on the circle through the center to another point on the circle. Okay? Half of that diameter, so in other words, from the center to one endpoint on the circle, that's called the radius. Okay? That's that red. And then this blue line here, guys, this blue line is very confusing sometimes because people see it and they say, wait a second, but it goes from an endpoint on the circle to another endpoint on the other circle. Shouldn't that be a diameter? No, that's actually called a chord. And it's a chord because it is a segment that goes from one point on the circle to another point on the circle, but does it go through the center? No. So, you know how I love to put those always, sometimes never? If I asked you, is a diameter a chord, would that be always, sometimes never? A diameter is always a chord, guys. A diameter is always a chord because it does go from one endpoint to another. But what would it be if I said, is a chord a diameter? Actually, never. Because a chord, by definition, never goes through the center. A diameter can be a chord. Guys, listen to what I'm saying. By definition, a chord is any segment that goes from endpoint to endpoint. But it doesn't necessarily go through the center. So a diameter does meet that criteria. A diameter is always a chord, but a chord is never a diameter. Well, okay, so I guess you could put sometimes, fine. All right, but if it was a true or false, is a chord a diameter? False. Yes. Yes, that would be wrong then. Yes. Okay? Now, there's a formula for the diameter. Okay, diameter is equal to 2 times the radius. And there's a formula for the radius. The radius is the diameter divided by 2. You need to know that because we're going to work with area and circumference. Hopefully you remember, we've already talked about this, but hopefully you remember that the area of a circle is pi r squared. That's the area. How many square units are within that circle? And then we have also what's called circumference. Circumference is the perimeter of a circle, basically. It's the distance around the circle, not the space inside of it. The space inside of it is the area. But the distance around that circle is a circumference. That's the perimeter of the circle. And circumference is equal to diameter pi or 2 pi r. Because 2 times radius is the same thing as the diameter. Yes, sir. Yes, sir. You could write it if you want as 2r pi, but usually in math world it's 2 pi r. It's the commutative property, guys. If you wanted to write it as r pi 2, I don't care. But it's 2 pi r. Thank you. Awesome question. Now, when we're dealing with circles, guys, we're going to be dealing with angles and arcs, okay? An arc is a piece of the circumference. So in this particular case here, if I put an A and a B here, this is an arc. And we've talked about arcs already, haven't we? Yeah, we talked about arcs. We know how to label arcs. If you don't remember that, I suggest you go back in time and remember it. There's a central angle theorem, okay? When we're talking about the measure of an arc, we're talking about the degrees that that arc has. The measure of an arc is degrees. Please remember this. Degrees. Measure is degrees. Arc measure, measure of the arc, we're talking about degrees. And the central angle theorem states that the measure of an arc is equal to the central angle. So if this central angle is 30 degrees, the measure of this arc is also 30 degrees. Okay? Huge on the SAT here. Huge. Huge. Then you have another thing. Yes, sir. In protractors, the thing that moves creates the angle. That's the angle, and then the other part is for the circle? Correct, correct. When you are creating an angle on a protractor, the interior angle, let's say, is 30. If you were to connect that top circular part together and make that arc, that would also be 30. Yes, very good correlation there, son. Very good. No, thank you. Then you have what's called the interior angle theorem. And the interior angle theorem states that the arc measure, so again, I know you guys probably forgot, you would write this like this. The measure of arc AB, that's going to equal twice the angle. So if this angle here is, let's say, 40 degrees, then the measure of arc AB would be 80 degrees. It's twice the interior angle. And I hope you remember that's how you write an arc. You did the little circular part, little arc, and then the letters. Yes, sir. For arc AB, the measure of arc B, the degrees of this circular part, that is 80 degrees as well. It is double the interior angle. Arc AB here, okay, would equal, in this particular example, 30 degrees. The angle measure of this part of the circle is equal to the central angle. When we're talking about arc measure, we're talking about the degree measure, not the length, the degree measure. You got to memorize this, guys, because now I'm going to throw a curveball at you. Now I'm going to talk to you about the length of the arc. The length is the physical distance. If I were to go with a little ruler, and I actually want the distance of this, how long is that part of the circle? That's a percentage of the circumference. This would be as follows. Let me erase this. It would be the central angle divided by 360 times the circumference, which is pi d, or 2 pi r. Or, if they just give you the arc measure, since the arc measure is the same as the central angle, it could be the arc measure over 360 times pi d, or in other words, times the circumference. So for this particular case here, guys, if I wanted to know the length of AB, not the arc measure is 90. But if I want to know the length, first of all, let's say my radius here, let's say this is circle 0, let's say my radius is 4. The length of this would be my central angle or arc measure, which is 90, divided by 360, times my circumference, which is diameter pi. If my radius is 4 here, what's the diameter? 8. So this would be 8 pi. Make your life easy, guys. Reduce this, that's 1/4, times 8 pi, and that would equal 2 pi units. Whatever it is, miles, feet, inches, meters. Yes, sir. I don't know what you mean by second arc measure. That's why it's an or, buddy. The central angle equals that arc measure, correct? Now we're talking about length of arc, hence length of arc. Yes, sir. I could tell you to leave it in pi form, or I could tell you actually calculate it. If I told you to calculate it, it'd be 2 times 3.14. Yes, sir. Now, last but not least, sector area. Sector area, guys, is literally the area of this whole slice. Think of it as a slice of pizza. It's the area of that whole slice. How many square units are inside of that piece of pie or that pizza slice? And the sector area is the central angle divided by 360, or the arc measure divided by 360 times pi r squared. Sometimes they give you the central angle, guys. Sometimes they give you the arc measure. That's why you got to know both ways. So in this particular case here, again, my central angle is 90. So that means that my arc measure is 90, because central angle equals the arc measure, vice versa. Let's say that my radius this time, again, let's do 4. I want to find the sector area. I want to find the area of this pizza pie slice. It will be arc measure, or central angle, which is 90, over 360, times pi r squared, which would be 16 pi. Reduce, please. Make your life easy. That's 1/4 times 16 pi. And this would be 4 pi units squared, because we're talking about an area. Okay? Now, I've only got a few minutes left, so I'm going to try to fly and do as many problems as I can. I'm going to fly, watch the video. So if you want, you don't even have to take notes right now. Just pay attention and watch it later. I got to fly. Okay, I want to try to do the best I can here. Okay, so find the circumference here. Okay, and find the circumference and not the r, but the area. So circumference here, guys, will be 2 pi r, or in other words, diameter pi. So 6.4 pi. Done. If I tell you to find the actual value, multiply 6.4 times pi, which is 3.14. The area is pi r squared. So 3.2 squared times pi. 3.2 squared is 10.24. So this would be 10.24 pi square units. Circumference is linear, area is squared. And again, if you wanted the exact value, just multiply by pi. Next, find the measure of AB. Okay, measure, we're talking about degrees. Length, we're talking about distance. So on an XY axis, this central angle is 90. So if this central angle is 90, my arc measure is equal to the central angle, which is 90. So this is 90 degrees. What is the length of AB? Well, let's see what my radius is here. This is 1, 2, 3, 4, 5, 6, 7, 8. My radius is 8. The length would be central angle over 360 times the circumference, which is diameter pi, 16 pi. This goes to 1/4 times 16 pi. This would be 4 pi units. Length is a distance. It's a distance. Measure is a degree. Find the sector area. Okay. Well, this distance right here is 14, isn't it? So that's my radius. So my sector area here would be central angle over 360 times pi r squared. So this would be 1/4 times 14 squared, which is 196 pi. 196 divided by 4 is 49 pi units squared. Go ahead, guys. Go to your next class. I'll finish this up now. Have a great day. Thank you. God bless you. Bye-bye. I'm sorry. There's another example down here. Okay. Find the measure of angle ABC. Well, if this measure is 60, and that is 2 times the angle ABC, angle B here would equal 30 degrees, because this angle is half of the arc. Or in other words, the arc is twice the angle. Number 5. If AB is the diameter of circle K, what are the coordinates of point K? Well, guys, point K is the center. And if that's the center, we need to remember the midpoint formula. And the midpoint formula is x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. So my midpoint would be -4 plus 8 divided by 2, comma, 5 minus 3 divided by 2. So my midpoint would be 4 over 2, which is 2, and 2 over 2, which is 1, and that's my center. That's point K, 2, comma, 1. And last but not least, I want to find the measure of INS, and then I want to find the slopes of IN and NS in order to prove that triangle INS is a right triangle. So, first of all, I want to first find the measure of angle INS. Well, let's think about this, guys. This is a pretty good one. This is the diameter. And this diameter is a straight line. What is the degree measure of a straight line? 180. So that means, since this is the central angle, won't this arc measure also be 180? Well, if that's the case, isn't this an interior angle? And doesn't this interior angle intersect this arc measure? So that is half of the arc measure. So this angle, angle INS, is 90 degrees. So right off the bat, we proved that triangle INS is a right triangle. Secondly, let's prove that triangle INS is a right triangle by finding the slopes of IN and NS. Well, the slope of IN, I'm going from -10, 0 right here to 6, 8. So am I not going up 1, 2, 3, 4, 5, 6, 7, 8? So my rise is 8, and my run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. My run is 16. So my slope of IN is rise over run, which is 1/2. Now let's look at the slope of the intersecting line here, N to S. The slope of NS would be down 1, 2, 3, 4, 5, 6, 7, 8. So I went down 8 over 1, 2, 3, 4, over 4. My rise over run here would be -8 over 4, which equals -1/2. And guess what? What do we know about lines when they have negative reciprocal slopes? That means that they're perpendicular. Therefore, this is a perpendicular intersection. Therefore, it's 90 degrees. Therefore, triangle INS is a right triangle. All right, brothers? So thank you very much. I hope you learned a lot. Have a wonderful day, and I'll talk to you later. Bye-bye. Okay, sorry about that, guys. I'm a fool. I am a fool. I messed up here. This is not negative 1/2. Maybe I should learn how to divide. Negative 8 over 4 is negative 2. Hello? That makes 1/2 and negative 2 negative reciprocals of each other. My bad. Thank you so much. I'm sorry about that. Negative reciprocals. So you got to flip the 1/2 and multiply by a negative. So again, these two guys right here are negative reciprocals of each other. So therefore, they're perpendicular lines. Therefore, that's 90 degrees. Therefore, triangle INS is a right triangle. Thanks again. Sorry about that, and have a wonderful day. Bye-bye.